Morning, ladies and gentlemen. As Suzanne said, I'm Luke Allen. I'm currently a part-time lecturer and a PhD student in U.C.C. I have just completed my PhD insofar as I've submitted, but I have yet to defend it. My background, believe it or not, is actually industry. I have only been in U.C.C. since 2006. Where I completed my last master's degree there, which is Information Technology for Architecture, Engineering, Construction. I generally worked internationally and nationally with various terms such as a contracts manager, contracts engineer, commercial manager, project manager, etc. In basically power, construction, the oil and gas industry, pharmaceutical industry, heavy manufacturing, etc., in various countries around the world, such as in the Middle East, in Europe, Far East, etc., etc. Today, I'm going to talk about a project that I worked on, which is a real live project, which is why I chose it. And this is a paper that I produced with two other co-authors, who are also PhD students. And it's in relation to a building in University College Cork that we wrote this paper on. And it involves using IT to produce a simulation of the actual building and come up with suggestions as to what needed to be done to make the building more energy efficient and carbon neutral, if you like. To begin with, just generally, I mean, we all recognise at this stage what's happening with respect to energy, carbon neutrality, etc., etc. We're also, I'm sure, very aware of the Kyoto Agreement that our government has signed up to and how we need to change to become more energy efficient. Some of the subjects that I lecture in U.C.C. Relate to modelling. For example, I used to lecture to undergraduates with modelling and visualization, mainly using Bentley and Autodesk, Revit, and MEP, etc. But also to master's degree students, I lecture virtual construction and virtual engineering. The virtual construction in conjunction with CITA and the new master's degree that has recently been set up by them, and as part and parcel of the scheduling and planning module that I teach for CITA. And basically everything we do in the Department of Civil Engineering that I'm involved in has got to do with IT and employing IT in relation to energy efficiency and carbon neutrality, etc., etc., etc. So we can see that we have to do something in relation to buildings in Ireland, either new design or those that are existing. And whilst I appreciate we have a downturn in construction at the moment, the reality is that throughout Ireland and Europe, about 18% of buildings are old buildings, they're constructed buildings. And one of the things that we need to do is to upgrade these buildings, to make them more energy efficient, etc., etc. And again, this is why I decided for this particular presentation we would use a project that we looked at in relation to a building that's actually 110 years old, and it's the civil engineering building in University College Cork. Now, please, Suzanne, if I'm going over the time, so throw something at me or do something. Okay, so what we did basically is we looked at a three-dimensional model in relation to the energy simulation analysis of a live working building in University College Cork. We all recognise in U.C.C. that a 110-year-old building needs to have something done to it to make it more energy efficient and to make it cost efficient as well. And for that reason, we decided to put down in black and white exactly what was inefficient and how to make it more efficient And the results of the paper that we produced were U.C.C. putting into action the conclusions, i.e. changing things within the building to help U.C.C. save money and become more cost efficient. It was the purpose, as I said, was to develop an energy simulation of an existing building to make it, if you like, more efficient, etc. Now, the thing about the building itself, whilst we would make recommendations as to how the building could be changed and made more energy efficient, the reality of the situation is it's an old building and U.C.C. don't want to change the character, the external character of the building. So whilst we would look at energy efficiency in changes to the external envelope, the reality is that they would actually never be put in place because the building would be out of character with existing buildings around on the campus. So for example, beside the building you have an old observatory building and you have other buildings that are of the same sort of age as the civil engineering building. So in reality, U.C.C. wouldn't accept changes to the external envelope. However, they did accept a lot of the recommendations that we did with respect to the internal part of the building. Of course, we did an analysis of the building performance itself. And as you see, with respect to the old buildings that I mentioned earlier on in Ireland and in Europe, a lot of them are not up to date in terms of the materials, etc., that can be employed to make them more energy efficient. There's also an awful lot of talk nowadays about building information modeling and how you can use BIM and building management systems, etc., to receive data to help you make the buildings that you're responsible for a lot more energy efficient, etc. And indeed, one of the buildings that we employ in University College Cork is the Environmental Research Building, which was designed to be as energy efficient as possible at the time and using as much natural ventilation as possible rather than mechanical ventilation, and using various environmentally friendly building materials and design, etc. And indeed, as part of our research in U.C.C, we have fitted the building with various wireless sensors to monitor the likes of CO2 levels, temperature, lighting, etc., to try and determine what is the most optimum user comfort that we can provide for such a building. I'm not going to talk, if you like, about new building design, mainly because of the fact that we're all aware at this stage that in new building design we try and employ the most up-to-date methods, etc. So we are looking, particularly in this presentation, with existing buildings and how can you upgrade these existing buildings to meet levels that are energy efficient, are carbon neutral or whatever, as part and parcel of the overall policy of the government to meet the Kyoto protocol or agreement, whatever. So I think mainly a lot of what's going on nowadays, as I said, maybe a downturn in new construction, but certainly the potential there in terms of renovation and refurbishment is very, very big. The software can point out the key building elements that give rise to the likes of CO2 emissions and energy consumption, etc. And basically what we did in our simulation was use 3D modeling and software to give us, as I said earlier, in black and white, actual figures that we present to the Buildings and Estate Department of U.C.C and say to them, look guys, here it is. here it is in black and white. We were all aware, by just looking at the building, that it needed to have some sort of work done to it in order to try and save costs for U.C.C. Costs being a big thing because when the recession came in, the government reduced its donation to universities, and in particular to U.C.C, by 17 million per annum. And that's a lot of money for U.C.C to lose per year. So obviously, U.C.C began earnestly looking at other ways that they could reduce costs. Hence the reason that the Carbon Neutral project that I'm involved in, and this presentation is about, and my other two colleagues are involved in, was all about trying to save U.C.C money. Here it is, the objective was to better understand the energy utilisation profiles of a building, i.e. the civil engineering building, and how the elements and systems of the building impact the energy use itself. So the process basically was to gather as much information as we could from the likes of buildings and estates in terms of documentation. Obviously the site visit wasn't too difficult. We are based in the civil engineering building. It's the department we work for. And any other outside or external consultants that were involved in various aspects of the civil engineering building. Created a 3D model of it, set it up for simulation, and then run the simulations. Last but not least, we also looked, and this was particularly my area, was to look at the financial aspects of the changes to the building and prove to U.C.C authorities that the actions that they take as a result of this paper would save them money. And it's like anything, put it down in black and white, show the savings, and people will immediately take interest. Now the building itself, as I said, it's 110 years old. It's 22 metres by a height of 14 metres. Square area is 1854, and the volume is 9,300 metres squared. It's a 3-storey building. The external walls are 550 millimetres. Now, before we did the paper, the old single glazed buildings, believe it or not. The ventilation system was, we'll see this later on, not mechanical. The central heating system was fed by a natural gas powered boiler that was providing not just to this building but to other buildings in U.C.C as well. And old cast iron radiators, etc., were the heating system. So what we did was we needed to create a 3D model of the building. One of my colleagues sat down, worked on the actual design, or not, well, recreating the building in 3D, if you like. We then had to take that information and feed it in, if you like, to a simulation situation. And basically, as a result of what we did, we got the results that we were able to present to U.C.C. Now, as I say, the project that we're involved in is part and parcel of a carbon neutral project, a externally funded project that is providing the money for at least one PhD student. So this paper was, if you like, in the interests of that project. That's the building itself. It's relatively old. It's got both sloped and flat roof. It's over 3 stories. The only new part of the building that's been added has been this part here. The rest of it is as was when it was first built. As I said, single glazing. Not a lot has been changed internally or externally. That's the first floor plan. We have offices for various lecturers here. We have a drawing office here. We have a lecture theatre at the end, etc., etc. Now, unfortunately, this hasn't come out as good as I expected, but the building was originally constructed as a chemical laboratory building, and the ventilation system is built up through various vents up through a turret at the top of the building, which is still there, and all of the vents are still there and operating, etc., etc. There were also under window open vents. The idea being that any of the chemical fumes, etc., etc., would be naturally drawn out of the building and things like that. As I say, the ones that are still in use, despite the fact that I said the actual shaft itself, the main shaft at the top, is out of use, the under window ventilation is still operating, etc., etc., and can prove to be very cold during the winter. The radiators, the heating systems are old cast iron radiators. Natural ventilation, apart from open windows on the main doors, was under the windows as well. And no, there is no air conditioning system, which can prove a problem on the first floor, as two of the main rooms are computer laboratories. And the amount of heat, when you have 40 or 50 computers in one room, can be quite large. But there was no air conditioning system to get rid of that heat, if you like, apart from students opening the windows. And the unfortunate thing about them doing that was that pigeons, if they didn't close the windows when they left the laboratory, pigeons came in and basically did their job all over the computers, as they do. Okay. Part of the modelling included taking the various elements, the building elements, and putting them into the model. Also adding in exact furniture arrangements and the lighting system, etc., etc., etc. Then, once we created the 3D model, what we did was we imported into another parametric CAD system, which was basically Revit MEP. And all of the things that we added in terms of the HVAC and lighting, etc., 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 was also input as well. Once we had that done, we basically looked at the space properties, and we added as much information as possible into the model to try and reflect as accurately as possible the existing building as it was. We used an IES plugin to Revit MEP to carry out the simulation. And this is just a snapshot of the GUI as it turned out. So we've added all of these properties, etc., etc., etc. The simulation, based on our algorithms that were defined in the European Building Performance Directive, etc. We did a number of simulations, and we got load reports, etc., etc., from the software that we had used. Okay, as I said, the scenarios that we looked at for the building there were 4 scenarios. Now, we looked at wall renovation, externally adding insulation. Now, as I said earlier, this is never going to happen. U.C.C. won't allow that to happen because they want the character of the building retained. But it was something that we had to look at to try and make the building more energy efficient, and was part of our simulation. Now, as I say, maybe down the road, U.C.C. will one day say, well, forget about the character, energy costs are so large nowadays that you will have to change the external facade of the building, and yes, external insulation in some form will be put onto the external envelope of the building. The roof hadn't, and well, it wasn't until after this report, wasn't insulated, hadn't been. The windows, as I mentioned earlier, were single glaze, they weren't double, and they were old, very old wooden windows. And then, so by those three individual analyses, we also did a combination of all of the three scenarios. If we had been allowed to do all of the three things that we had wanted to do, we did an energy simulation of that as well. So the building as it was, the average heating loads, 228 kilowatts, the electricity consumption, 20 kilowatts, the average number of operating hours was 2,096. So per year, we were looking at 597,360 kilowatts of heating loads, and we put in a 80% boiler efficiency. We also used 41,920 kilowatts of electric energy per annum. And of course, the total area of the building that we used in our figures, both occupied and unoccupied, was 1854 meters squared. After the analysis, what we found was that the existing building, as I said earlier, we came up with a figure of 597,360. The building as was. After we had suggested the renovation, etc., we had reduced that to 209,600. So that was a saving basically in kilowatt hours of 387,760, which, as you can see, is quite a large reduction. We also showed that we were able to reduce the CO2 emissions by 19%. And we'll see now later in a particular figure that we showed that the roof insulation led to 33% savings. The replacement of single glaze to double glaze resulted in 11% savings. And finally, the holistic scenario where we took all three, the external wall included, into consideration, showed that we were able to show a reduction, an overall reduction from the existing to the proposed of 65% in savings. Obviously, that type of figure makes buildings and estates sit up and take notice. Okay? And there we have it. The building, before any of this was done, as you can see, was quite large. And I suppose the most important thing here to look at is not just the way it was, but taking all three scenarios into consideration, the way it could be. Okay?
Is the 33% what was originally being lost? Is it a percentage of the loss?
It's a percentage saving. It's a percentage saving, yes. So 33% could be saved in energy loss because we insulated it.
On that particular entity?
On that particular entity, just the roof itself.
Okay.
So these are all the individuals. So for example, when we did the simulation involving changing the windows, only the windows,
yes,
we have an 11% saving.
Fine.
When we did it purely for the walls, if we were externally insulating the walls, if we'd been allowed to do that, we showed that we could get a 19% saving. But if you take all of the three together, the windows, the roof and the wall, an overall saving is 65%. Okay, and here are just some figures. As I said, it's repeating what's in the table. Just to give that comparison of SEI benchmarks. Previously, in the building before we did the paper, you can see that we're well off the mark. Well off the mark. Even having done what we have suggested, you can see that we are still slightly over what is good practice. But you know, it's a big improvement on the way it was. So, having used the likes of Revit MEP in conjunction with an IES plugin, as I said, you've seen the figure. It originally was 597,360. Looking at the cost of gas at the time that we did the paper, etc., the annual bill for the civil engineering building was 35,000. Okay. We dropped the total heating load to 209,600. That brought the bill down to 12,576. That's a saving of 23,000 per annum just for the civil engineering building. Again, when you present these figures to the likes of buildings and estate, then they sit up and they take notice and they say, okay guys, we will do something about the situation. If the President ever questioned it, here's the backup. Here is the paper done as a result of using IT, 3D modelling and energy simulation to prove that we need to take action. So it was clear that savings could be made. It was also clear that CO2 levels would be brought down. It was proven that we could help the Irish government reduce the carbon emissions, etc., the greenhouse effect, etc., and thus help in reaching the Kyoto Agreement. We figured that basically the saving of the 23,266 had an overall payback time of 14 years. Now, you appreciate that in the paper there are an awful lot more figures and formula that we used to get this that I can't show here because I don't have the time. But all of these were worked out and financial analysis done, etc., of all aspects of it, whether it be the double glazing, whether it be the wall insulation, the heating, whatever it was. After we had completed the report, there was a heat meter put into the civil engineering building, and all of the changes that we recommended, apart from the external facade, were put into place. For example, all the bulbs were changed to energy efficient bulbs. We had PIR systems, so if there was nobody in the building or in certain parts of the building, the lights would automatically go out. If somebody came in, they'd automatically go on again, etc., etc. The heating system was totally refurbished, double glazing was put in, etc., etc. And heating demand decreased by 23%. They also put in the likes of various sensors and things like that to feed into a building management system, through which various data was obtained, etc. That's it, ladies and gentlemen. I hope I haven't been too long, etc., etc. And I think questions and answers, if there are any, will be later on.
Yeah, we'll take them at the end, actually.
And now I shall hand over to Joseph, who will carry on with this presentation. Thank you very much, ladies and gentlemen.